So I already brought down the information from previously when we calculated the E-cells for these in a previous reaction sets practice problems. So you can go back to a previous lesson that shows how to do this if you want to figure out how to calculate the E-cells. In this case, we're just going to use the formula, and we do need to pay attention to what N is. In this scenario right here, do you see how there's 2 and there's 3? Now, these, of course, one of them is going to be flipped, yada, yada, yada. But what ultimately is going to happen is this one's going to have to be multiplied by 3, and this one's going to have to be multiplied by 2, because whichever one's going to be the flipped one, it's going to be the oxidation one, which is going to be this one. You're going to have to be able to cancel out those electrons. You can't cancel 3 and 2. So our total electrons involved ultimately is 6 electrons. 6 electrons will be leaving this one and be used by this one. So 6 is going to be our N value here. Go ahead and look at the other ones and their N values. So in this scenario, our copper with the 2 electrons, copper goes to copper plus 2. The electrons are going to go on the positive side on the right. And then this one, if we were just doing the AG, notice I've just got 1 electron involved. But since it's 2, and this is why it's 2, I've got 2's in front of those. So yes, there are 2 electrons that are being used on this side. So in this one, my N is 2. And then I kind of have a similar scenario going on here. So if I have 2 Cl minus going to Cl2, then plus 2 electrons. Those, it's only the 2 because of the way that this is diatomic. That's actually talking about 2 chlorines being split and leaving up 2 electrons, or being made actually in this scenario and losing 2 electrons. And then over here we have zinc plus 2 electrons going to zinc. So again, it's the 2 electrons that are made here that are used down there. So N equals 2 in that one. So my delta G in this first case is -6 times 96,500 times, and that's times my E cell, which is 2.752 volts. And that gives me 6 times 96. Make sure you always put that in right. 96500 times 2.752. And that's going to give you that your delta G is equal to 1.59 times 10 to the 6th. And that's a negative. The negative wasn't lost. And this one's going to be coming out in joules, because this is actually a volt is a joule per coulomb, and this is a coulomb per mole, and then this is a mole. So cancel, cancel, and we're left with joules. So if you were asked to solve for it in kilojoules, it'd be 1.59 times 10 to the 3rd kilojoules. So then in the next one, I can probably squeeze this one in over here. So delta G is equal to -2 times 96500 times my E cell, which is 0.756. Bring this over, 2 times 96500 times -0.756. So that gives me -1.45 times 10 to the 5th. And as I'm looking at it again, that's in joules for the same reason as before. So it's actually going to be 1.45 times 10. Actually, that's 146, isn't it? 1.46 times 10 to the 2nd kilojoules. And then in here, delta G is equal to -2 times 96500 times E cell, which is -2.120. 2 times 96500 times 2.120. Notice that I have two negatives in here, so this one is going to be positive. 4.09192 times 10 to the 5th. Let me kind of fix that one. 4.092. Again, that's joules. If I had wanted it in kilojoules, there we go. Divided by 1,000.